Hello everyone, today we are going to go ahead and learn about how to simplify radical expressions. Okay, so I'm going to share my screen with you and going to talk about it. Okay, first of all, let's take a look at the real world example. Because believe it or not, there's a lot of real world example for this kind of expression. Okay, so we have, oops. It's too big there. All right, so first, let's take a look at this scenario. It say, Jacob, a huge baseball fan, asked his sister, did you know that the distance between the two bases of a diamond, the baseball diamond, is equal to the square root of 8100? How can Sarah learn to estimate the square root of 8100? In this concept, you will learn to evaluate radical expression, okay? So first of all, let's review. Radical means a square root or a cube root of the fourth root, the fifth root, and so on. We have a few of these notation for this, okay? So some radical would look like this. So the little number that we have on the top, we call this one is the index. Another word for index is root, okay? So the index is the same thing as root. So for this one, we call this one is the 3. So we're gonna call it the cube root. All right. And then the part of radicals, of course, the sign right here is called the radicals. And then the little number that inside is called the radicand. Okay, the radicand. Okay, so that is the basics. We are going to take a look at the scenario again, right? We want to calculate that one to help his sister to calculate that. Okay, so Jacob would tell his sister to rewrite the square root of 8100 or 8100 as a radical. Yeah, so okay, so you start with the square root of 8100. Now, back in the day when you learned this, you know that whenever you have the square root of a times b, this one can be split up, split it up, okay, into square root of a times square root of b. You see this? So exactly that's what's going to happen. We are going to rewrite the 8100 as 81 times 100. Yeah, so we are going to split it up. We know the square root of 81 is 9 because 81 is a perfect square of 9. And then square root of 100 is 10. Okay, so we're going to have 9 times 10 and that will give us 90. So now the sister and you both know that the distance between the two bases is 90 feet. Yay! Of course, if you play baseball, you already know this, yeah? But it's still cool for some of us who are not really good with sport. Now we know. Okay, so let's go ahead and use that to evaluate some of this, okay? The distance between the two bases, we already know that. We are going to evaluate some perfect square right here. Okay, so when you take the square root, you wanna pay special attention. Now, what I said the square root is, even if you don't see the number right here, the index, yeah, is 2. Yeah, it's the lowest of the radical. You good? All right, so that's why all of this is actually have the square. If you want to, you can put the 2, but nobody ever do that. Okay, so that's just gonna be the notation of square root of 16. Square root of 16 is, well, 16 is a perfect square of 4. So 16 can be written as 4 times 4. Yeah, so therefore square root of 16 is 4. Same thing, the square root of 25. 25 is a perfect square. 5 square give you 25. So square root of 25 is 5. Okay, and 81, square root of 81 is 9 because 9 to the power of 2 will give you 81 or 9 times 9, yeah? Same thing with the next one. We have the square root of 121, that's 11. And 36, you already know that. 169 is 13 times 13. Wow, when it comes to the cube root, you know the index gonna be the 3, right? This one is 27. What really happens is, if you split the 27 into 9 times 3, then you see this one, we have the 3 already. It cannot be factored anymore, like differently, yeah? But the 9 you can factor into 3 and 3. So there's a number that multiplied by itself 3 times to give you 27. So therefore the cube root of 27 is 3. Yeah. Same thing with 125. 125, you can write 125 as 25 times 5. You see? And 25 can be split up into 5 times 5. So you know evenly 5, 5, and 5. There's no leftover. So each of them, when you multiply by itself 5 times 5 times 5, it will give you 125. So therefore, the cube root of 125 is 5. Okay, so that is the basic of it, yeah? Next, we are going to go ahead and take a look at how we evaluate the radical and rational exponents, okay? So we have learned this one, how to solve it already, but today we're gonna learn more in depth, okay? So supposedly you have x to the power of m over n. Then you can see the number on the top is going to be your power, okay? And they go in here, the x power of x. And then the number at the bottom, we call them the roots or the index, it's come outside, okay? And this one is the same thing as the root n of x to raise to the power of m, okay? So that's a basic definition. We are going to take a look at 2 simple rules for this one. And then we do some practice at the end, yeah? So first of all, we have the rule number 1. If you have the square root, again, this one is 2, yeah? Square root of x is the same thing as x to the power of 1/2. Right here, the x's power is 1 and this one is 2, you see? So square root, you can rewrite them as x to the 1/2. Cube root with the number 3, you can write them as x to the power of 1 over 3. The fourth root, you can rewrite them as x to the power of 1 over 4. Okay, so the exponent as a fraction. And then, so you can generalize it into this. Okay, if you have the nth root of x, then you can write them as x to the power of 1 over n. Doesn't matter what number that is, yeah, you can always rewrite them like that. So for example, if you want to find the 5th root of 32, you see, then you will need to, you can rewrite this one as, it's the same thing as the base is 32 raised to the 1/5 power, okay? There we go. So we are going to take a look at a few examples to demonstrate this rule. So here we go. Well, for the example, okay, let's take a look at the example here. We have 8 to the 1/3, 8 to the power of 1/3. So that's gonna be the same thing as cube root of 8. Yeah, and 8, you can rewrite them as 4 times 2. 4 can be written as 2 times 2, and there's another 2 there already. So each of them evenly can have a 2, 2, 2. So cube root of 8 is 2. This one, 125 to the 1/3 is the same thing as cube root of 125. Yeah, 125 is the base. So you put them inside. And then the index or the root come outside like that. And we already know this from the previous example. We have is 5. So cube root of 125 is 5. Yeah. Same thing, we have, for example, right here, we're gonna do one of each. So for example, if you have 100 to the 1/2, okay, 100 to the 1/2, you are going to rewrite this one as the square root of 100. You see, that's just gonna give us a 10. And then this one, same thing, is the 4th root of 16. This one is going to be the cube root of 27. Yeah, and cube root of 27 is 3. Because 3 to the power of 3 give us 27. Yeah. All right, so the 25 and the 16, you can do that like by yourself, okay? Let's go to the rule number 2. Rule number 2 said, Oh, now we don't have a 1 on the top. We have a fractional exponents. So we have x to the 3 over 2. Now, we can rewrite the 3 over 2 as 3 times 1/2. Yeah, so rewrite this one as x to the 1/2, everything raised to the 3 power. You see the 3 is the power, right? So we x to the 1/2 is the same thing as square root of x. You see, x to the 1/2 is the square root of x. Then you can put the x outside, and that will help us evaluate any numbers. Yeah, as long as we know the square root of it or the cube root of it. Yeah. So this is the general form. As you can see, it's kind of repeating from earlier. Yeah, the root come outside or the index come outside. The power come outside. Like that. Okay. Let's take a look at some example. 8 to the power of 2 over 3. Okay, so 2 over 3 can be written as 2 times 1/3. You see? So we can have the q 8 to the power of 1/3 and everything raised to the power of 2. Oh, my bad. This one is a 2, okay? There we go. That one is a 2 right there. So q root 8 to the 1/3 is the same thing as q root of 8. Yeah, and q root of 8 is 2. So we have 2 come inside, and then the 2 is a power outside. 2 squared is the same thing as 2 times 2. So that will give us 4. Similarly, the 25 to the 3/2 can be written as 25 to the 1/2 and everything raised to the 3rd power. Yeah, and this is the same thing as square root of 25 raised to the 3rd power. And this will give us 3/3. 3 to the power of 3. 5 to the power of 3. And that will give us 125. Okay, so pretty much you can evaluate any numbers. As long as you know they're perfect square or perfect cube, you got it. Okay, there's a few examples on the bottom as well. So let's work on a few of them. We have 100 to the power of 3 over 2. So this can be written as 100 to the power of 1/2, right? And then raised to the 3rd power. Okay, so power of 1/2 is the same thing as square root of 100. And being raised to the 3rd power, you got a 10 to the power of 3. And that will give us 1,000. Yeah, so that will give us 1,000 for the first one right here. Next one, this is the same thing as 16. Well, the 4th root of 16, right? And then you raise it to the 3rd power. So this would be, the 4th root of 16 is 2. 2 raised to the 3rd power would be 8. Done. Same thing over here. If you want to pause the video and try by yourself, please do that. This is a cube root of 1,000, and then you square it. Cube root of 1,000 is 10. When you square the 10, you're going to get 100. Boom, boom, boom. Wow, we're on to last example. Gonna have the index is 2, and then inside the 25, everything raised to the 3rd power. Wow, this is just square root of 25, which we know is 5, right? 5 raised to the 3rd power is 125. Oh, and if you haven't noticed, it's actually right here. It's the same problem, right? Yeah. Okay, so that is part 1. Now we know how to evaluate expression with the perfect square or the perfect numbers. Yeah. What if I have a student maybe asking me this? What if the number inside are not a perfect numbers? So say you have a square root of, so say you have square root of 48. Yeah. How can you do this? Now, if you have a number that's different than a perfect square, then you will try to rewrite them as a perfect square first, okay? So 48, you can write them 48 as, what is it? 16. Yeah, 16 is a perfect square and times 3. So this will be the same thing as square root of 16 times 3. Square root of 16 times 3 is the same thing as square root of 16 times square root of 3. Now 3, you cannot take a perfect square of 3 is not a perfect square. Yeah, so you cannot take the root of that. But 16 is a perfect square. Indeed, it's 4. So we're going to rewrite the final answer as 4 square root of 3. Okay, let's try another one. What if I have the square root of 120? 120 is not a perfect square. However, you can rewrite them as a perfect square, right? We can rewrite this one as, what is it? 4. Yeah, 4 is a perfect square. And then 30, 4 times 30. 30 can be written as 6 times 5, right? Okay, and 6 can be as 2 times 3. We don't see anything that can be a perfect square or repeating twice there, except the 4, right? So we can rewrite this one as square root of 4 times 30. And that will be square root of 4 is 2. So 2 square root of 30. Okay, and that's it. So it was the same way if you have the cube root. Yeah, so say you have the cube root of, let's see, 81. Now, 81 is not a perfect cube number, but we know that 81 can be written as 27 times 3. Yeah, so we know the cube root of 27. Yeah, is 3. And then this one can be written as the cube root of 3. So the answer is 3 cube root of 3. Good. Let's try another one. Cube root of, let's see, 250. Oh, 250 can be written as 25 times 100. But 25 and 100 is not a cubic number, right? Let's think of another one. Let's see. 1 to the power of 3 is 1, some cube, perfect cube, okay? You gotta know this. 1, and then 2 to the power of 3 is 8. 3 to the power of 3, 3 cubed is 27. 4th cube is 64. 5 cube is 125. 6 cube is 216. 7 cube is 343. And so on. 8 cube is 512. 9 cubes is 729. And 10 to the power of 3 or 10 cube is 1,000. Okay, so we know that this one can be written as 125 times 2. Yeah, 250 is the cube root of 125 times 2. Cube root of 125 is 5. And then that's leave us with cube root of 2. This is not going to give us an even number, so we're going to stop here. Okay, so that is basically that's all you have to know about the number that inside the square root or the cube root. Yeah, how to simplify this. All right, so on the next part is to, we are going to go ahead and convert between the rational and the radical exponents. Okay, so part 2, let us go. Wow, what a beautiful flowers. And you know why I put that one there. Okay, so here we go, let's start. We know this one, the power is 1. So when we're trying to convert from, this is radical. Yeah, when they have the root, we call it a radical. And the number, the little number right here are the roots. Yeah, or we call them the index. Of course, if you have nothing, that's a 2. Yeah, and there we go. We're gonna change them into the order form to express them in a different way. This one is called rational exponents. Okay, rational exponent. It just means a fraction, exponent as a fraction. So let's first start the cube root of x. Now the base is x, right? So you're gonna always keep the base the same. All of this should have the same base, which is x right here. And coincidentally, all of them have the x inside just a power of 1. So we are going to put a power on the root, okay? So x to the power 1 and over, 1 over, 1 over. All of this will be 1 over something. Okay, and that something is going to be your, ta-da, the root. Okay, the root number. So the root number for the first one, or the index, this one we call it the 3. So x to the power of 1 over 3. Okay, or 1/3. Next, we have the fifth root of x. That will be x to the power 1/5. The fourth root of x will be x to the power 1 over 4. The seventh root is going to be x to the 1 over 7. And this one, of course, the square root is the same thing as x to the 1/2. The sixth root is x to the 1 over 6. Okay, that's it. Pretty much it, like that. So as you can see right there, the number on the top is representing your power, right? Or the exponent of the x right here. And then the number on the bottom is represent your root. So that's the reason Ms. Dope have put the picture right here, so you can see. Now this one, the top is a flower, so it's rhymed with power. Yeah, flower, power. And the bottom, yeah, you guessed it. Underneath the ground, that one is the root. So we're going to always put the power over the root. Yeah, as your fractional exponent, the power over the roots. So that means this is the power. You see, the number on top always represent the power, and the number on the bottom represent the roots. Yeah, so just looking at the number, we know right away the root have to be the 2 right here. And feel free to put a 2 or not. Yeah, I'm not going to put it. The 3 right here will be a root 3, and right here the bottom number is 4, so that's gonna be the 4th root. Yeah. All right, so the number usually is go on the top like this. Let me go ahead and erase this one. It's kind of sloppy. All right, let me retry that. Okay, there we go. Oh, much better. And the base is x. Each of these have the basis x, and the power is the one that go in the top, on the top, right? Just like the flower right here. We're going to put that one is power of 1. And we don't need to put a 1 there. Inside, this is the power of 2. So we're gonna put x squared. This one, the third example, x3. So x cubed, go right there. All right, so we have successfully converted from rational exponents into radical exponents. I mean, not exponent, just radical form, okay? These two are exactly the same. They're just written differently, okay? Let's take a look at some example. Of course, the one that inside is called the power. The one that outside is called the root. So we're gonna keep the base the same. In this case, is k. And then you're going to put the power on top, the root on the bottom. The power is 7 and the root is 4. So 7 over 4. Okay. Let's keep going to the right one. We have the exponent is 3. Yeah, so x, this one is a power. The outside is the root. So we're going to have 3 over 15. So 3 over 15 can be simplified into 1/5. So x to the 1/5 power. Okay. Next, we have u to the power of 4. And the root, oh, we don't see any index there. So of course, the root is going to be a 2. Okay. So we're going to have u and then power over root. So 4 over 2. 4 over 2 can be simplified. Now notice that every time you're working with fraction, you always want to simplify it or reduce it, okay? Into the final form. Next, we are going to convert back from exponents, has a fractional exponent there, back into the root. So we know that the number on the bottom is called roots. So whatever number that's there, that's how many root that is. So for first one, x to the 1/5 means root 5 of x to the power of 1. You see? Next one, same thing. The root is 3. So we put the 3 right there and y to the power of 2. This one, the root is 2. So that is just going to be a square root, a regular square root. The base is m and the power is 3. So we see, wow, today is such a lesson that you can learn how to convert back and forth, back and forth. Now you know how to work with all the radical and rational exponents and how to convert between them. Okay, so any question that you have about this, please ask your teacher. We are here for you, and we are always here to support you, and we want you to learn the best that you can, okay, to get you ready for higher classes. And of course, to grow your knowledge in your learning. So thank you. And we hope to see you again in the class. Let's show up, do our assignments, and let's do the best that we can so that we can pass and we can move on. Okay? Bye, guys.